Hello, viewers. Thank you for joining us as Voyageurs National Park Association brings you our Night Sky series. As Voyageurs National Park anticipates receiving Dark Sky Park certification this fall from the International Dark Sky Association. So just a couple notes. If you're not familiar with who Voyageurs National Park Association is, we are the charitable partner of Voyageurs National Park, and we work with the national park to support them, such as the Dark Sky Endeavor, providing funding to have lighting that reduces light pollution, bringing you this educational program. We also provide youth education, environmental education programs, and we're able to do the things we do in supporting the park because of viewers and supporters like you. If you're not part of the Voyageurs National Park Association, you can find out how to become a part of it. That we always accept volunteers as well. And one of our volunteers of the moment is Astro Bob King, that he's here to present this. He's an amateur astronomer and has previously been the editor of the Duluth News Tribune and, or excuse me, the photo editor of the Duluth News Tribune. Excuse me, am I talking today? And he has his own blog on astronomy. You can see that on the bottom of your screen, astrobob.areavoices.com. So please welcome Astro Bob.
Thank you very much, Jackie. Appreciate that. And hello, everybody. Great to see you. Well, actually, I really wish I could see you. I would love to be able to meet everybody, and I hope to someday. In the meantime, we'll meet this way. But great to have you here. And I hope you have clear skies tonight because it's a special night. We have the full moon happening tonight, and it'll be pretty close to full tomorrow night as well. So a little fuller tonight, 2 nights of the full moon. Before we get started on the presentation today, we're going to look at a couple of current events and then from there move into our main topic, which is about our Milky Way galaxy and also the Andromeda Galaxy, which is the farthest thing that most of us will ever see in our lifetimes. Before we do that, I want to mention that because it's now September and I look outside and I see some of the leaves changing, we also have a new monthly calendar. Here we have it right here. You can see from skymaps.com. We have a new monthly September star map there for you and a list of events that you can see during the month of September. Again, that's at skymaps.com, and that link will be with this presentation on the Voyageurs website. Once again, a little reminder, if my voice starts to sound really weird for a moment and slows down, I'm not moving into another dimension. It's just my slow internet connection. And if you have any questions that come up during the presentation and you want to ask them, hold on to them for a second, write them down, and then I'd be very happy to address them as soon as we're done. So with that, I'm going to head over to my presentation today. And we're going to start with, as promised, the full moon. And you'll often see that the full moon in September, especially early September, if it's not close to the autumnal equinox, that would be the harvest moon. But this one is further away from that. So it's called the full corn moon. But in our region here in northern Minnesota, the local Native American peoples call it the leaves turning moon, which really is perfectly fitting, especially since the colors of the full moon kind of resemble and harmonize with the colors that we're now starting to see in our landscape. I was out in the woods yesterday and I noticed some touches of red and touches of orange in maples and a little bit in the oaks and yellows in the forest floor. So things are already moving towards the fall. So tonight the moon will rise at around sunset, and that's because if you remember, when the sun sets in the west, the moon is 180 degrees opposite. So sun sets, moon rises in the east. I hope you can find a location where you have a nice wide open horizon facing towards the east, because not only will you see the moon rise, but you'll also see this dark gray purple band beneath the moon that we've touched on before, and that is the shadow of the Earth on our planet's atmosphere. It looks very kind of murky and strange, and what is that? Almost like an approaching weather front, but what it is our planet's shadow. And we can see it briefly from about the time of sunset until about 20 minutes after that, before the darkness of the sky overcomes the shadow and it blends in. So be sure to watch for that. We have moonrise tonight around sunset, and also the Earth's shadow. For more details on that, I did a blog today about the full moon tonight. So you'll find like how to find the moonrise time for wherever you live. That's right there in the blog. Another event I want to be sure to alert you to, I'm really excited about this one. Maybe some of you saw the great conjunction of the moon and Jupiter a few nights ago. Just like you looked out in the south and whoa, there was the moon, and boom, right next to it, the planet Jupiter. Well, we got an even better conjunction coming up here. This one is between the waning moon, so this takes place a few days after full, and the planet Mars. And Mars is getting really, really bright, like we talked about last week. And the two of them will be just 1 degree apart. So that's just 2 moon diameters apart from each other. You can watch for that on Saturday, September the 5th, and look towards the east, and you'll see these 2 brilliant objects come up together, starting around, give or take, 10:30ish or so. So it's a little bit later than normal, you know, but it's still within our time frame of being up at that hour. Nice conjunction. Before we touch on Andromeda, I want to talk a little bit about our own Milky Way, because once the moon, which is really getting bright, obviously it's full moon, once the moon is out of the sky and darkness returns, that will provide us with an opportunity to see the Milky Way at its most spectacular. I would say that the months of September and August, these are the best times, because the Milky Way is out high up across the sky, kind of like the way you see it in this photo, at a slant across the southern sky. It's high up, goes all the way across the top of the sky and then down to the northeast. As soon as it gets dark out, you can see this magnificent band. So it's worth a trip to the countryside. And here you can see in this picture that I also managed to squeeze in the bright planets that are near the bottom of the Milky Way, Jupiter and Saturn. So if you just remember that when Mars is in conjunction with the moon, that's also about the same time that the Milky Way will return to the evening sky. There it is. This was taken from a local lake. You can see that beautiful band. Interesting shape to the band, isn't it? It's not the Milky Way as we see it. It doesn't just fill the sky with clouds. It forms a distinct band in the sky, like a ribbon across the sky. And there's a reason for that. And it has to do with the structure of our galaxy, which I'm always hungry, by the way, and I love pizza. And just by coincidence, the Milky Way galaxy, that's the entire Milky Way, right? The Milky Way galaxy is sort of shaped like a pizza. It's flat and it's disc-shaped. The only difference between a pizza and the Milky Way, besides the fact that you can eat a pizza and you would not dare to try to eat the Milky Way, is that in the center of the Milky Way pizza, there is a bulge of stars, as we'll see in just a moment. Here we are, looking through the galaxy, through that pizza-like disk, towards the center, towards the bulge in the center where the stars are concentrated. You can see that the sun here is about 27,000 light years from the center. That's about roughly halfway from the edge of the galaxy to the center. The entire Milky Way is 100, I'll back up here. Yeah, 100,000 light years across. Now, when we look through the disk of stars, those stars pile up across the vast distances, whether we're looking towards the center, down the arms, or out the back. We're looking through the disk. Those stars pile up. Kind of the same way, if you look at a driveway that has gravel in it, a gravel drive, stars nearby or stones that are close to you, you can distinguish. But in the distance, those stones pile up and form kind of a blurry dense view where they kind of blend together. Well, the stars in our galaxy do exactly the same thing. As we look through the disk, across that distance, the stars all blend together, and that blending, as we look through the disk, produces a band across the sky, which we also call the Milky Way. So here's the band right here, and that's part of the summer Milky Way. We're looking right through the disk where the stars are concentrated. When you look above or below the disk of the Milky Way, the number of stars drops rapidly. You just, very few down there below the disk, very few above. We really do live in this pizza-like thing, the Milky Way galaxy. So it forms a band across the sky because we're right in the disk. We're there with those stars. We're not above it, we're not below it, we're in it. So as we look through it, we see this magnificent band. There's a couple of different ways to look at the Milky Way. You can see it as we do here on Earth. As I said, we're stuck inside the disk, so we see it as kind of a band. But if we could get in a rocket ship and get the heck out of the galaxy, shoot above or below it, we would see that we are living in a spiral galaxy. You'd clearly see our spiral arms, kind of the way we see spiral arms in other galaxies. And there would be the sun about halfway between the center and the edge. Oh, look at this diagram. Much too much going on, but we'll just pass through it so you get an idea. Mostly it's about how big we are, 100,000 light years from end to end. The disk itself is flat compared to that. It's only 1,000 light years thick. There's the bulge in the center. Here's where the sun is, right there in that disk. And when we look towards the constellation of Sagittarius, that's called the Archer. You can see that right now. That's where Jupiter and Saturn are close to. When we look towards Jupiter and Saturn, in that direction, we're looking towards the bulge, or the center of the galaxy. When we look towards the constellation of Gemini and Orion, the winter constellations, we are looking out of the disk. And so the star number drops off rapidly. We can still see the Milky Way, but there aren't as many stars when you look towards the center. So the winter Milky Way, even though it's a band, just like the summer, is much fainter than the summertime Milky Way. What's in a galaxy? What's all around us? Where do we live? Who inhabits a galaxy besides us humans? Well, stars, billions of stars. It's estimated that there are 300 billion stars in our Milky Way. And they range in size from everything like Betelgeuse, which is a giant red star, to stars the size of our sun, to very tiny stars that really aren't much bigger than the planet Jupiter. They're called dwarf stars or red dwarf stars. So they come in all these different sizes, and they come in all different colors as well. Well, you don't just have stars, but you've got some really cool stuff that you can see in binoculars and in telescopes, and even with the naked eye. If you've heard of the Pleiades star cluster, for instance, the Seven Sisters, it is called an open star clusters because it's a loose assemblage, a loose gathering of stars. So our galaxy contains open clusters, like this one here in Scorpius, nebulas, which are clouds of gas and dust, within which there are embryos of stars that are forming from the gas and dust. These are like nurseries, these nebulas, and they have these amazing shapes. This one is taken by the Hubble Space Telescope, and sometimes it's called the fingers of creation. There are globular clusters. They are made up of tens of thousands or even hundreds of thousands of stars, kind of like the open clusters, but they're much richer, and their gravity molds them into a very dense ball, kind of like a swarm of bees. And then finally, well, there's lots of other things, but one of our favorite ingredients of galaxies, besides the stars, are the planets that revolve around those suns. We have 8 planets that we know of, but some solar systems have more. And there are more than 4,000 stars we know of in our galaxy orbited by planets. So we've got this big mishmash. It's like a stew of primarily stars, but it's sprinkled in like you'd add salsa or something. It's sprinkled in with nebulas and clusters and stars and their planets. Galaxies come in different types. we're familiar with the spiral galaxy. These are just beautiful because they have a symmetry that is very pleasing to the eye. Our Milky Way is a spiral. And then there are the elliptical galaxies. They're called elliptical because they're oval shaped, elliptically shaped. These galaxies do not have spiral arms. They're very rich in stars, but they don't have dust in them that kind of helps to outline the spiral arms. Just masses of stars with a bright bulge in the center. And finally, the last major type of galaxy is called the irregular. And it's just a mishmash of all the different kinds that don't quite fit one category or another. This is a spiral galaxy too. One of the most beautiful things. These are some of the most amazing things to look at in the universe. The Hubble Space Telescope takes beautiful pictures of them, and many of them you can actually see in a telescope. So they're available, they're out there. How many galaxies are there? You're not going to believe this. At least a trillion. A trillion. Gosh. And we're really just familiar with one in a trillion. But I'm going to introduce you to another so that you can say, well, I need to expand my galaxy repertoire. And you can do that by learning where to find one of the closest galaxies to the Milky Way. It's also one of the largest nearby galaxies to our own. And get this, it's a spiral too, and it's called the Andromeda Galaxy. Here it is. I've abbreviated the constellations. And means Andromeda, Peg means Pegasus, Cass means Cassiopeia. Andromeda, the galaxy, is a little fuzzy spot located in the constellation of Andromeda. And here's the shape of Andromeda right there. I connected the stars for you. And Andromeda is connected to this big square that comes up in the eastern sky, about halfway up as soon as it gets dark out, and that's called the square of Pegasus. If you can find the square of Pegasus, you can work your way to Andromeda. But you can also use Cassiopeia, the W, which is a brighter group of stars anybody can find. Here, let's use Cassiopeia. There it is. I've got a map here. This is facing to the northeast, which is over here from my computer, around 9 p.m. in early September. So as soon as twilight is over, it begins to get dark, you're done with dinner, you're ready to go outside and have a look. Once the moon is out of the sky, and I do have to mention that the moon should be out of the sky. You're not going to see this clearly if there's a full moon. You're going to want darkness, right? So if you can find Cassiopeia, use the W, the top half of the W, as an arrow pointer, and it points right over to the right, about a fist to the right, to a fuzzy blob. Now, you may not see it immediately with your naked eye, depending on where you live. You know, if you're in the countryside, yes, you will see a little fuzzy spot there that will remind you of like a piece of the Milky Way. So use binoculars. Start here at the top of Cassiopeia with your binoculars, slide about a fist to the right, and look for a fuzzy thing. Here's what it looks like, kind of. There it is up there. Here we have our binocular user. It's got a bright center and a little bit of haze around it. Once you spot it in binoculars, well, then you can lower the glass, look and see if you can find it with your eye. And when you find it with your eye, I mean, stars are far enough away, right? The closest star beside the sun is the Alpha Centauri system. That's 4 light years away. This is 2.5 million light years away. We're going to learn what that means in just a moment. Here's a sketch I made. Binoculars are a surprisingly wonderful instrument when it comes to bright things in the night sky, like star clusters, like the Seven Sisters, but also you can see things in the Andromeda Galaxy. You can see the bright bulge in the center, the disk, and you can even make out faintly 2 of Andromeda's satellite galaxies. You know the way moons go around planets or satellites go around the Earth? Galaxies have other smaller galaxies that revolve around them. The Milky Way's got a whole bunch of them. Andromeda has 2 very bright ones, relatively bright, called M110 and M32. Both you can see from a dark sky with a pair of binoculars. Let's just look at the whole thing in a magnificent photograph. Look at that. Oh my gosh, what a gorgeous image this is. A time exposure of Andromeda. Here you can see the bright core where the old stars in the galaxy congregate, very dense in there. There's also a black hole inside there, a supermassive black hole. Speaking of which, we're going to make that our topic next week. We're going to talk about black holes. And around it, you can see, because the galaxy is tilted from our perspective, we can't see it face on the way you saw in the previous diagram, like looking down on top. We see it tilted from the sides, so the spiral arms sort of blend together, but they're outlined by this dark material. This is cosmic dust that's spewed out from stars when they explode as supernovas. And that dust gathers in the galaxy and it forms the next generation of stars inside nebulas there. It's all a wonderful system, how it all happens. And here you can see the two satellite galaxies, M32, and M110. 2.5 million light years away. Let's discuss just for a minute what that means. 1 light year is the distance a beam of light will travel in 1 year. And light travels so fast we don't even think of it. It seems instantaneous to us. We flip on a light, boom, it's right there. But it takes a little bit of time for that light beam to get to wherever it's going. It's traveling at, oh, I left out a 0, pardon me. It's traveling at 186,000 miles per second. Now, I don't know how many seconds there are in a year, but in a year's time, that adds up to about 6 trillion miles. That's how far a beam of light can travel in 1 year. How far is the moon in terms of light time? It is 1.3 light seconds away. So if you take a flashlight, and I know it's not going to actually make it all the way to the moon because of the atmosphere, but if you take a flashlight, just as an imaginary exercise, you point it at the moon, it takes 1.3 seconds to get there. And if you can imagine it bouncing back, it takes 1.3 seconds to come back to you. So round trip, 2.5 seconds. The sun, it takes a flashlight beam 8.3 minutes to get to the sun. So if the sun were to suddenly disappear right now, we wouldn't know for another 8.3 minutes. How about that? A little extra daylight before eternal night. And then if we start moving beyond the sun, the nearest star is 4.4 light years away. That would be the Alpha Centauri system. It's actually a triple star. And that's relatively close, but so far away that this star looks just like a point of light. To the Hercules Globular Cluster within the Milky Way, 25,000 light years. Oh, what a long time that light has to travel, doesn't it? 25,000 years to get there. The Andromeda Galaxy, 2.5 million light years away. Now let's put it in reverse. Light from Andromeda is traveling towards us, right? That's why we can see it in the first place. That light, when it reaches your eye, the night you go out and see Andromeda, that light left the galaxy 2.5 million years ago. 2.5 million years ago, and it has been moving at the speed of light for that long until it finally arrives right there inside your eyeball. Isn't that amazing? It takes you back in time 2.5 million years ago, way long ago. Some people ask, Bob, what's going on then? If it's 2.5 million years old, is this galaxy even there? That's a lot of time. I can guarantee this, it is there, because galaxy lifetimes are measured in the many billions of years. So 2.5 million years, just a drop in the bucket compared to the lifetime of something as enormous and complex as Andromeda. Look at this place. Okay, first of all, Andromeda, twice as big as the Milky Way. It's a spiral, but it's really a monster. And while the Milky Way may have 300,000 stars, this Hubble Space Telescope picture gives you an idea of how much richer Andromeda is. 1 trillion stars is what the estimate is. And remember, this galaxy is just one of at least 1 trillion others. my head's going to explode thinking about all of these stars and all of these planets. The universe is enormously rich, not only in materials, but in possibilities as well. Andromeda has nebulas, just like ours. You can look across millions of light years ago. Oh, hey, I recognize that. That's a nebula. Oh, those are stars. Oh, there's a globular cluster. This is a globular in the Andromeda Galaxy called G1. It's the brightest globular. I could see it even in my telescope, 2.5 million light years away. And although I don't have a picture of it, I wish I could paint, because then I would paint what Andromeda's Milky Way would look like too. Except they wouldn't call it the Milky Way in Andromeda, they'd call it the Andromeda Way, right? They would look up from a planet in that galaxy, let's say in the disk of that galaxy, halfway from the bulge to the edge, and they would see the dust and the spiral arms cutting across this sky, making a band of light like that. You would have a Milky Way, an Andromeda Way, just like our own, would have different form to it, but you'd instantly recognize it and go, we got one of those here too. Great thing about Andromeda, fascinating thing. Many galaxies are moving away from each other in the expanding universe. You probably have heard about that. No one wants to be near the Milky Way. I don't know what the problem is here. But the Milky Way and Andromeda are approaching one another rapidly, 893 million miles an hour. That seems super fast, but they're so far away, of course, that you can't really see the change in distance through your telescope or with your eye year to year. But astronomers have measured these speeds, and we are gravitationally attracted to each other because we're these big masses, and we're traveling towards one another rapidly. Now, you're gonna guess what's gonna happen. Are these two objects, are we gonna collide, the Milky Way and the Andromeda Galaxy? And if you said, I think so, you are correct. About 4 billion years from now. Wow. I mean, the Earth formed like 4.5 billion years ago. So this is way, way in the future. 4 billion years from now, our two galaxies will begin the process of merging with one another. They're going to actually pass through one another. And galaxies, by the way, can do this. Even though they look like they're made of solid stuff, there's tons of space between all of those stars. So galaxies can pass right through each other, do a little dance, and then merge together into one without a star hitting a star because of all that empty space between the stars. It's an amazing fact. Here's a little dance I'll show you. Down here in the lower right, you can see in this animation, the clock is ticking and the two galaxies are approaching one another. Notice that when they do, they feel each other's gravity very strongly there and move quickly. And they also distort one another's shapes and fling stars out in all these different directions. No stars may hit, but the stars will form different spiral arms and fly outward. Then eventually, it's not shown here, the two will actually merge together to form one single galaxy called, someone's already named it, Milkomeda. Oh, I don't like that name exactly, but what the heck. In other words, they'll form one giant elliptical galaxy. We will lose our spiral arms, and so will Andromeda. And instead, we'll have one of those ellipticals that you saw in the earlier pictures. Here's a photograph taken by the Hubble Space Telescope of two other galaxies in the process of merging. Can you imagine getting a seat, being able to watch this in the future play out? It makes me wish I could live to be 10 billion years old, just for the sake of watching that happen. Before we finish, I want to mention to you a brand new discovery just announced by a team of astronomy researchers. They use the cores of these bright cores of very distant galaxies. The cores are brilliant because they're powered by supermassive black holes. They use them as flashlights, as beacons around Andromeda. They're way in the distance. Here's the Andromeda Galaxy right here. And these orange dots are the quasars, these bright galaxies. They use these galaxies to probe the environment around Andromeda in the past couple of years. And guess what they discovered? They found that that galaxy, and here it is here. Remember, this is 200,000 light years across, twice the size of the Milky Way. They discovered an enormous, much bigger cloud of gas around the Andromeda Galaxy. Some of that cloud actually reaches 2 million light years in our direction. In other words, it's almost all the way to the Milky Way. Now we think the Milky Way also has its own halo around it. So at this moment, it's very possible that the halos of our two galaxies, Andromeda and the Milky Way, are actually touching and mingling in space. It's incredible. If you could see this halo with your naked eye, and you can't because it's really, really faint, but if you could see it, it might look something like this. It would be a huge glow around Andromeda, 3 times as big or as wide as the Big Dipper. Just incredible. And that's one of the most amazing things about science, and in particular astronomy, is that when you think we've got things all figured out, someone makes a new discovery and we go, wow, really? Things just get deeper and deeper and more interesting. Well, I hope you'll have the opportunity to see the Andromeda Galaxy sometime in the next several weeks. It'll be up all fall, so you can go out in October, November, December, January, right into the winter. And you can use the W of Cassiopeia to point you there. And of course, this presentation will be available if you'd like to revisit it and download the maps or take screenshots of the maps to help you find it. So right now, I'm wishing you clear skies, and if you do have any questions, feel free to ask. I'd be happy to answer. Thank you very much.
There's a few questions already. The first one is, do you think there is other life in the universe?
Yes, I do. I have absolutely no proof of it, but life just seems so tenacious and, given the right conditions, inevitable. And so I do think that there are other forms of life in the universe. Not like us necessarily, but I do believe in that. And I hope that you, me, all of us are around when that discovery is finally made. Perhaps it will be made on Mars when we bring back samples of Martian rocks in the next few years.
The next question is, could you point out where to find the Perseus double cluster in the Cassiopeia area?
Oh, that's such a nice question. I'm glad you know about whoever asked that, know about the double cluster. If you recall, the top part of the W points to the Andromeda Galaxy. The bottom of the W, the flat part on the bottom, if you look immediately below that, 2 fingers, right below the flat bottom of the W, that's where the double cluster is. It also looks like a hazy patch in the sky, kind of a milky spot, but when you put binoculars on it, you will be able to split it up into individual stars, 2 bright clumps of stars. It's a magnificent object, especially in a small telescope.
This question is a 3-part question. What happens to galaxies over time? Do they ever cease to exist? And what does it mean for a galaxy to not exist?
Wow, these are deeply philosophical, especially the last one. I love that one. Over time, they do evolve. The material inside the galaxy, the dust that you saw, those little curls of dust that look like the cinnamon part of a cinnamon bun, those do gradually condense through gravity into stars, and a galaxy will use up its dust over time. Lots of mergers happen. Galaxies, this is common in the universe. So a galaxy may merge with another galaxy and become a larger galaxy. There's other various options available, but ultimately, all of the material gets used up. All of the stars will burn out one day, and the galaxy will become dark. But this won't happen for so long that It's not a concern. We will have these magnificent objects for as long as there are people to look at. But great questions about galaxies. I hope I was able to answer some of those. But yes, they do evolve because stars evolve. And they do merge, which is fairly common.
All right, the last one I'm seeing here. Do you know if there will be any northern lights or falling stars this weekend in Voyageurs National Park?
Well, all good things are in Voyageurs National Park, so I'm hopeful all the time that you might see that. There are no meteor showers that are on the docket right now. There's always the possibility you'll see a random meteor any night of the year. They usually come at a rate of 5 to 7 per hour. But because the moon is full, it's going to make meteor watching this weekend, or near full. It's going to put a ding in meteor watching this weekend. What was the other part of the question? There was meteors and, oh, northern lights. The northern lights have been a little bit active lately. We've had a couple of very minor, what they call storms, where if you were under a dark sky, you could see a little glow in the north. And there is indeed a possibility during this week and perhaps this weekend that there will be a minor display of northern lights. That would mean a greenish glow near the horizon. So a small possibility, yes.
All right, I don't see any other questions coming in. So would you like to tell everyone what's coming up in the next session in 2 weeks from now?
Yes. Well, besides current events in the night sky, what you can see, I think it would be fun to talk about black holes. We did touch on them a little bit when we talked about those quasars beaming behind that big halo around Andromeda. So let's have some fun and talk black holes next week.
All right, as we get ready to wrap up here, just want to remind everyone that our Dark Skies Night Explorer program will be continuing this fall, so keep tuning in every other week. And we've got up here again, so you can find out more about Astro Bob's blog, as well as finding out more about Voyageurs National Park Association. So thank you, Bob, and thank you, viewers.
Thank you, everybody. Thanks, Jackie.